I think of myself as a robotics guy. I went to grad school at Stanford, ended up moonlighting in a pharma, and ended up building robotics for cancer research, drug discovery, and actually built a pretty successful company over the course of about 10 years. And after that period of time, I did, as Neil said, think of myself as an expert in robotics. I've been in and out of every pharma all over the world. And, you know, I thought I kind of knew what was going on. I'm obviously a techie, geeky guy. I buy all the newest gadgets. I'm one of those guys, stupid guys with too much money that adopts, the first adopter kind of guy, right? And yet, I got involved with Singularity University by coming to one of the first exec programs, so a week-long program. And after that week, I completely changed my mind of what it means to be an expert. Because in a week, I saw things in my space, both in robotics and in biotech, that I didn't realize existed already today. So as an expert in a space, how can I really feel good about myself if I don't know all the amazing stuff happening in my field? And what's more, there's these other fields, other areas that are moving really quickly that are converging and also disrupting our fields. So for myself, after I sold my business, I was like, wow, thank God I sold it when I did, because there's things happening in neuroscience, there's things happening in nanotech that are actually all converging together, and we're going to impact the business that I built, and I was never going to see that in any way. And so this is what we're trying to give you a taste of here over the course of the next few days, which is why we've interspersed robotics and a bunch of other things, because they are all converging and intermingling and having an impact on every part of our lives, every part of our businesses, industries, and society as a whole. So with that, I'm going to jump into robots. And we actually, since we just had a nice AI talk, it turns out that AI is really easy, but AV is really hard. So I'm gonna actually see if we get the technology set up here. So perfect. All right, good. What does everybody think of when you think of a robot? Come on. What is it? R2-D2, right? Everywhere I go around the world, the first thing I see is this, right? And then there's a couple more that we see on here. And then what's the reality today, right? There's a couple things that we see, mostly like industrial scale robotics. There's toys and Roombas, these other things. How many people have a Roomba? Not too many, not too many. Actually, this is not a very techie crowd here tonight for some reason. What's your Roomba's name? Rob Nail. That's a very unique name for a note. That's the first one there. Turns out iRobot, they did a poll, and like 2/3 of the people who had Roombas named them something. They had a name for it, right? Rosie or Donald, or apparently Rob Nail's one now too. Interestingly, about 1/3 of those people said that they had taken that Roomba with them traveling. So there's something interesting happening with our relationship with these devices now that they're doing some new things. So where are we with robotics today? So we don't see robots like what we expect, right? The expectation is R2-D2 and C-3PO should be running around. We have beam robots, right? We've got the Telepresence robots running around, and I would encourage you all to try them. But it's not quite the same, right? We're not there. And why is that? Salim and Peter kicked off with exponential technologies, right? This is my curve of the difference between our expectations in a linear world versus an exponential one, right? And on the bottom, we see there's this great wave. Where is my flying car, right? We've been talking about flying cars for a long time. You would think that by now, with all the crazy technology, we'd have one. But our expectation is that we'd have flying cars, but actually, we're on an exponential curve of technologies, right? And that exponential pace is doubling from 0.001 to 0.002 to 0.004. It just looks like nothing's happening, but it's doubling, right? And then at some point they converge, right? So in robotics, there are 3 key pieces to that puzzle, right? The amazing pace of processing power and computer technologies that we have today is really driving a lot of capability with robotics. The sensors that we have on our bodies are getting cheaper and smaller and more powerful, and we can integrate them and use them in wholly new ways. And with robotics, the language of programming robots has shifted over even in the last 15 years, from needing a PhD roboticist to program assembly code and machine language, to writing in C++, to actually having open source development libraries where kids today are programming robots that code is living on and being found in wholly new uses and applications. So when that realm crosses, we get into this different phase. It is changing so quickly. There's so much progress. There's so much innovation that it seems magical. It seems chaotic. It seems scary. And today with robotics, we're right here. Right? So I'm gonna run through a bunch of examples to kind of show what that means. Since we're focused on medicine, there's about 6 key areas that I think in this decade, you're going to see starting to be heavily disrupted in the medical field. First, around capability replacement. We're already seeing these. We've seen them for some time, but there's a lot of new stuff on the horizon. Things that are actually helping us with the various tasks that we do on a day-to-day basis. Actual enhancements to what we're capable of doing. A lot of biomimicry is really starting to creep into some cool stuff. Therapy, we'll talk about that in a minute. And then there's some just big transformative stuff. Overall, there's some big implications. One, anybody seen the movie Terminator? Yeah, usually when people think about robots, the first thing they think of is, I don't want to be killed by a robot, that they're scary, they're usually, there's something going on that they're a little freaky. That's not going to happen just yet, but there are some signs that that's coming sooner than we would like. But the big implication short term is on jobs, right? Daniel actually threw up a slide around the future of the anesthesiologist being a robotic platform. Well, I think any job that requires accuracy, precision, speed, consistency, needs to be very cheap, or isn't very safe for humans, is perfect for robotics. And where technology is today, it means we're going to start to see a lot of new jobs that we have today being taken over by robots that can do them much, much better, much more cheaply, much more accurately, consistently. They don't drink, they don't get distracted. Robots are really, really good from that standpoint. Right? I think of the pharmacist at Walgreens that we go to, and this is an amazing person who's had many, many, many years of schooling to count pills and put them in a bottle. Right? That is not going to happen, right? That is a job that will not last very much longer. And there's a lot of companies working on that one specifically. But any job that needs accuracy, precision, and others is subject to being disrupted by robotics. So today, the vast majority of robotics are industrial scale robotics. There are hundreds of thousands of robots out in the world manufacturing cars, manufacturing devices. This is always a fun one. Everyone's seen the I Love Lucy skit. Well, this is an industrial scale robotic pick and place machine, basically doing the same thing. The company that I built was building similar-minded robotics. It was in relatively industrial scale robotics for drug discovery and cancer research. This is a system that is basically a robot that is for high throughput screening. It's in a laboratory environment. It's basically just putting a lot of different steps together very accurately, very rapidly, and very consistently. The novel thing that we did with Velocity 11 is we created a software platform that allowed the scientist to say what their experiment is and say, I want to run this experiment, rather than having a PhD engineer having to write machine language of, okay, move robot arm from here to here, open gripper, grab, close gripper, move. It's now to the point where you can set up a system like this in a few hours rather than a few months. Right? And this is being propelled largely by this open source development movement. There are hundreds and hundreds of really interesting robotic hardware platforms out in the world that different companies are selling, different innovators are building, but then the software development is on an open source platform. Which means if I come up with a really novel new use of that drone that Marco was flying this morning, and I put the software up online, a 10-year-old kid can say, hey, I want to do something slightly different. They'll take my code and then build on it for the next person. This is how it goes exponential, right? Because no matter what company you have, even if you have 10,000 engineers, software engineers working on programming robotics, there are hundreds of thousands of curious engineers, kids, programmers, coding, similar things. Right? And as Peter mentioned, you can't compete with that. Right? So one of the really cool things here is in manufacturing robotics, Baxter robot is a good sign of more things to come. This is a robot that costs $22,000 that has about the same reach and scale of a human and can do basic activities. The magic here is that it can be taught by almost anyone. You essentially walk it through what you want it to do. I want it to pick this thing up, move it over here, assemble this piece, now go, now do it 1,000,000 times. Now obviously that's going to replace, at $22,000, that is very, very competitive on any manufacturing labor union jobs. But what is interesting, so we're going to lose a lot of jobs to manufacturing and other, but you can have a line manufacturer running that, actually teaching that robot. So somebody who is an assembler on the line can now take this robot and teach it how to do the job, or teach it to do a new job next week, and you've now transformed, the guy lost his line manufacturing job, but now he's a robotic specialist. Right? So there's some interesting opportunities of transition, where jobs will transition, but there's a big wave of this coming at this price point. Okay. In medicine, we have a long history of industrial scale robotics being brought into the medical clinics and other. Obviously, radiology is one. Catherine Moore will be talking. She's from Intuitive Surgical. She will be talking a little bit about the amazing capabilities of robotic surgery. Right? This allows a surgeon to actually go to a scale and a precision and an accuracy with no stress and strain that is impossible for a human to do, right? And I would foretell that in 20 years, we will look back on this time and say it's barbaric that humans ever put their dirty, grubby hands inside a human, right? That's a ridiculous thing to do. When robots can be totally sterile, totally clean, they're not going to drop stuff inside and then forget it when they stitch it up, right? This is happening now, and you'll get to hear more about it from Catherine as well. So we talked about the Roomba a little bit. There are a lot of new, okay, nope, sorry. My interface isn't quite perfect just yet. So there's a lot of new activities at home that people are experimenting with. Again, in an open source development platform. This is the Willow Garage PR2. This is a research platform. Willow Garage is actually the company that spun out to start the Beam Telepresence robots that you see driving around. But they built this and sent it to a lot of universities for students to program. Do you recognize what this robot is doing? This is a very complicated process of taking laundry dumped on a table and folding it, right? Now, I'm pretty certain as soon as this gets down to a reasonable price point, I will buy one. Actually, I will buy one before it's even remotely a reasonable price point. I just had a kid now 4 months ago, and the amount of laundry you have to do with this kid is a nightmare. So if I can get him, the robot, to change the diapers, to fold the laundry, I think I have a new market. So if there's anybody that wants to start that business with me, please let me know later. Out in the world, there's a lot of other activities that we do that are really hard for us. So moving patients is a really good example, right? There's a lot of strain. Doing it consistently, very sensitively, is a difficult task. And so Reba is a good example of a robot that can actually do a task much better than a human can over time. A lot of other things like the meal assistance, there's hundreds of really interesting examples. The Wii Me is something I saw at CES this year. CES is the computer electronics show in Vegas where all the cool new technologies get launched. Essentially, you take this little massager, you put it on your back, and it autonomously massages you. And I think one of the reasons robots don't get a good name is that kind of marketing. It's like, it really looks tacky and gimmicky and other, when that is an incredibly complicated robotic platform that literally couldn't exist 10 years ago for less than $1 million. Like, literally, that's the kind of capability that we have in these robots. We couldn't even do these things years ago. So Telepresence robot, I highly, highly encourage you to play with the Beam robots that we have. Also talk to Marco. I think he has a couple of the Fellow robots here as well. Fellow Robots is one of the SU companies. The Beam robot, I think it's like a $20,000 platform today. It's amazing. And Daniel talked about it being in the clinic and in the hospitals. I actually went to an event. I was in DC. I logged into one of these robots in an X Prize event in San Francisco. I roll in. The first person I run into is Robin Williams. I have a 10-minute conversation with Robin Williams. Then I talked to Lieutenant Governor Gavin Newsom. and then these women come and want to take pictures with me. Guaranteed if I was there in person, none of that would have happened, right? So you have a short window of opportunity to arrive in some event as a robot and get all the attention. So, encouraged. They're getting much smaller. Right now, these are passive camera devices that we can swallow. PillCam's been around for a little while, but there are people working on actually translocation and having these move and manipulate, so they're actively moving around in your body. And they're getting smaller and smaller. I think Raymond McCulley will talk about nanorobotics. These are biological robots that can detect markers and do stuff, right? Release drugs right at the exact spot. And then there's a whole realm of companions that are actually very practical, very useful, and very interesting in some new ways. The Pero is probably one of the most successful robots out there being used for cognitive impairment. So people that have issues with pain and others, this is a robot that actually interacts with you. It senses, it has feedback, and it actually will help stabilize emotionally distraught people. The Aibo, the Sony robot, was around several years ago. Now the Now robot, and in the center here, is an amazing teaching tool that costs about $16,000, and it literally runs around. There are now college students who go to this World Games. It's called the World Expo. It's a soccer match. When I was in college, now it was 20 years ago, in this competition, we would build this big round thing that would roll. You'd have to load the soccer balls in it, and it would roll around, and it would sort of sense tape on the sides, and then it would shoot a ball roughly. Today, college kids, the 18-year-old kids, are programming teams of bipedal robots to actually have strategy in soccer. So this is a big difference. And then the Plio is an interesting little toy. I'll show a quick little video here, where this is, I think, a $300 or $200 little toy. What's unique about this is a almost a fully autonomous robot. And it has these characteristics that it turns out it'll fool an infant, a toddler, into thinking it's alive, right? And it turns out about a 2-year-old thinks this is a creature, thinks it's like a cat or a dog. 3-year-old is a little not quite convinced. A 4-year-old knows it's a toy. I think that's a good analogy for where robotics are today, actually. Pretty much all the robots that we see are at that sort of toddler stage. The way they communicate, the way we communicate with them, what their capacity is. And they're growing exponentially, just like a toddler does. There's other companions out there that are being developed in a wholly other market. Much like the DARPA and the defense industry has funded tons and tons of research, this is another industry that is funding a lot of interesting research. While it may seem a little icky and strange, you can imagine there's actually a lot of therapeutic benefit for disabled, sexually dysfunctional, other elderly markets. Sexual health is a really important part of our lives, and robotics may very well play a big part of that in the future. Daniel showed a little bit about the exoskeleton. There's a few different versions. Exobionics is a great example of a company up in Berkeley. They started as a DARPA grant for helping soldiers carry more cargo and weight, and they realized that if you can help someone who can't walk to actually stand up and walk for the first time and interact at that level, it is a dramatically transformative experience. And there's other prosthetics and replacement type things that we have. And this young man here actually had elective surgery due to an injury. And he has a replacement hand that is allowing him to do pretty much all the things that you would normally be able to do. I mean, tying your shoe is a pretty complicated thing. And it also gives him some enhanced capabilities that the rest of us don't have. And so we're at a phase now where there's some additional capabilities that we're getting with robotics that we didn't have before. The Luke arm is another great example from Dean Kamen at DECA. Just a quick note on this. Dean built this prototype in like less than a year. And it's taken him 5-6 years to get through get through the 501k compliance. He's had the Class 1 appealed 3 times before he could get this out. And they are working on nerve control and brain control interfaces as well, but just for the initial version, it took them many, many years to just get it out to disabled who are much needed. Daniel showed this video with the brain-computer interface, and I'm not going to go through it too much. Let's see if it'll just play quickly. This woman basically is paralyzed, has an embedded interface, and is able to control a fully articulated robotic arm. And Daniel made this connection too. What if it wasn't embedded? What if this was actually a non-invasive headset? There's some amazing research. We may hear more from the neuroscience team in the next 2 days from Harvard and the University of Washington, where you connect two people with these things, and then what can you do with that? Right? So I'll save that one for later. Robots don't have to be hard and cold. You think in a hospital environment that are interacting with patients, you want it to be warm and soft. Right? So this is other lab up in San Francisco. Saul Griffith is one of our ongoing faculty. He's designing textile robots using pneumatics. There's some amazing things you can do with a lot of strength and power through pneumatics that you can't do with other motors. And then when it gets really fun is you need to carry loads out in the wild. You can obviously abuse your robot. That's something that is probably going to be more and more common as we go along. But this is a lot of really interesting research coming from Boston Dynamics, largely DARPA contract. This is about helping soldiers carry a lot of stuff out in the world. And it starts to look a little scary. The Wildcat up in the top right is very, very recent. You can see them, the capabilities getting to be very similar to what actual animals and others. These are devices that can carry hundreds of pounds. So that is a scary sight that I never want to see when I'm hiking out in the woods. You can imagine the fright you will see when the first time that happens, which will likely happen in our lifetimes. And then they also are adding new capabilities to these robots, where if you abuse your robot, it has the capability of actually throwing cinder blocks at you. I'll talk about why they're developing that capability in a minute, actually. Oh, and this is it. So DARPA launched a robotics challenge about 1.5 years ago for disaster relief. So they looked at Fukushima nuclear plant and said, this is terrible, we can't send humans in there. What do? We don't have robots to do it. So they launched this platform, and they built this robot. It's called Petman. It's now called the Atlas platform that they're using, and it can run through all kinds of obstacle courses and do some amazing things. And this is the future of robotics here. This is where these are fully autonomous robots. This isn't remote control. This is a robot that we've told it to go from here, walk down there, do some activities, and it deals with the environment that it's faced with. And then this Halloween, somebody decided to dress this thing up. This is actually from a little while ago, but that's one of the scariest things I think I've seen in a while, right? I think that is more frightening to me. This is where it starts to harken back to the Terminator world, right? This starts to feel a little scary. Now, flying things, we got to see Marco and the small flying machine. There's a lot of really cool research happening out in the world. This is a dragonfly made by Festo. This is just a beautiful biomimicry robot that has 4 fully articulated arms and wings that are independently controlled and is just absolutely beautiful. I'm sure they spent at least $1 million building this, and about a month after they showed that, an Indiegogo campaign, basically a Kickstarter-like campaign, got kicked off. They raised more than $1 million, and I'm expecting to get delivery of mine, hopefully anytime soon. They're not delivering yet. But there's a new model where you can be inspired and raise a ton of money to do these things by sharing that inspiration and finding crowdfunding in new ways. So I just thought that was a really interesting example of how quickly development is happening. And then, of course, there's a dark side to all this, right? One of the things that is a must for me in all these talks, anytime I talk about robotics, I want to talk about putting weapons on robots. So Terminator is a bad scenario. I think it's horrible. But it turns out our weapon of choice right now is UAVs, right? We have drones that we put weapons on that kill most of the people that we kill today. Good news, sort of good news, is that the DoD has a very clear policy that we will not kill people without a human saying, okay, it's time to kill that person, right? So the drone will find a person, target, and say, hey, can I shoot this guy? And a human has to intervene and say yes. That's today, right? There's a lot of things that are, the autonomy in these robots are increasing and improving, and so we're seeing that line get pushed, and you should be in the discussion with your politicians if you care at all about the future of warfare and how this comes down to us. We talked about Matternet, looking at the delivery of medicines and goods. This is a video of a pilot program that they ran in Haiti, basically delivering materials. There's a lot of other uses. We had a team this summer looked at actually doing agricultural inspection. You can imagine other opportunities like delivering stuff, and there are businesses that are looking at delivering pizza and papers and others all over the place. And then last week, a few of you, everybody knows about the Google car, right? You know that there are cars driving themselves on the roads today, correct? This is just a quick Google video of what it really looks like on the street. Full test case in the wild. This is, you know, not a test. This is them driving around. The more exciting piece for me is that every major car manufacturer has said that they are virtually on the verge of having fully autonomous capabilities. Cadillac even said by 2015 they would have self-driving on the highways. Cadillac, not the most innovative of companies, right? But Nissan, Mercedes, BMW, Toyota, over the last month, all of them had said by 2020 they would have virtually fully autonomous capabilities. It's kind of in the 90% autonomous, right? There's still a few things that humans got to be intervened. Of course, after they said that, Google said they'd have it by 2017, and then Tesla said 2016. And I don't know if you guys checked your watch, but 2016 is 2-3 years from now, right? So you can buy a car that basically drives itself within 2 to 3 years from a real car company. That's exciting. Anybody have kids? You all have Mindstorms at home, right? Or Lego we do. If you don't, I highly recommend it. These are amazing robotic platforms that you can build almost anything. Lots and lots of different sensors and a great capability with the controller platform. And ultimately, implications on jobs is a huge one, right? Foxconn said that they're building a factory for 20,000 workers to build 1 million robots to displace 500,000 workers. That's one company. This is a huge wave. We're also going to be afraid of how these things look and interact with us in the beginning, and we have to realize that, like in the case of the Google car, that will save 1 million lives a year. There's 1 million people that die every year because they're drinking or other, right? Morals and ethics, and ultimately what it is to be human, I think is the end line for us. And Neil showed this. At some point, we're going to realize that that device that we have running around is, we have to say it's alive, right? Like the little Plio robot, a kid really thinks it's alive. So how much more capability does it need for us to validate that that thing is actually alive? There's not nearly enough alcohol in the room for that, so once we have that, we can have that conversation a little bit later tonight. So with that, I want to thank you. If you're afraid of robots taking jobs, here are probably the two books I would highly recommend. Race Against the Machine is written from an economics perspective about technological disruption on jobs. Must read, absolutely probably one of the most important economic books currently. And then Robots Will Steal Your Job from Federico was a student 2 summers ago. Really fun approach. It's actually a good thing. This technology is going to take us to whole new places that is actually going to be very good for our lives. I don't want to fold laundry anymore personally, so I'd be very happy to turn that job over to a robot. Thank you very much.